Hi guys, so before we get into another example, here's another useful need for statistical analysis and probability. Control charts are useful if we are examining data over a period of equally spaced time intervals or in some sequential order. So let's say we're observing short circuits over time or blackouts or anything where we want to keep that type of resource under control, and we need to pay attention to if something's out of control. So here's a sample of a control chart. You'll have your mean in the middle, and then you jump up 2 or 3 standard deviations here, or -2, -3 standard deviations here. And your x-axis is time. So when we are examining these control charts, if the x distribution is continuing in more or less the same manner, we say that it is in statistical control. So we like to keep things in control in lots of situations. So this is a way to observe data to determine, is everything under control? So how do we determine if something is out of control? Well, our first signal is if 1 point falls beyond 3 standard deviations of the mean. That's going to be a very big outlier that should jump out and make you a little bit nervous. Signal 2, 9 consecutive points above or below the mean. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points and they're all below my mean, that should be a signal that there's something that's not out of control, not in control. We kind of want it to go an equal amount above and below our mean. And then our third signal that we look for is at least 2 out of 3 points in a row lie beyond 2 standard deviations of the mean. So let's say we're going here, and then there's 1, 2, and then we go back down. That's 2 out of the 3 in a row would be beyond 2 standard deviations of my mean. That's also considered out of control. So this is something we will apply in our next example.